Ready? All right. All right, well, good morning, everybody. My name is Stannard, and today we're going to talk about the biggest professional embarrassment of my career. So, quick show of hands for people in the audience. Who would describe themselves as like a business owner or a startup founder or someone who's basically had total responsibility over a product? Quick show of hands. All right, we got a few of you. How many of you are software developers? All right, there we go. You're both going to take some things away from this talk today. I am both a CEO, I'm a software developer, and if some of you have seen any of my NDC talks I've given before, it's usually about our open source technology we work on, which is Akka.net. My company, Petabridge, been around for about 11 years. We're the commercial entity wrapped around Akka.net, and it's basically a actor model implementation for .NET. Akka.net will enter the picture in the story a little bit later. But our business is really built around offering services for people who are trying to adopt Akka.net in their own companies. So consulting, training, and support has historically been what we've done. And the problem with this business model is that it's not very scalable. The types of customers we support are building things like sports betting platforms or industrial grade manufacturing or meter data management for like really large electric utilities. The quality of software engineer you need to be to support the people doing that type of stuff is very, very high. So as a result, our organization needs to have high standards for what we do and how we conduct business. And these are the standards we have written down in our company onboarding materials when we're doing interviews, hiring, training, that sort of thing. And I won't read the slide to you, but the basic gist of this is that we have to be very precise. We have to pursue excellence. Good enough is not okay. We've got to make sure that things are safe, given the types of systems our technology is deployed into. This is a story about how we completely failed to live up to these values, which is why I personally find it so embarrassing. So this story is about another quick show of hands. Who follows me on Twitter? All right, so most of you, this will be brand new information to you. I have been bitching about Sdkbin for years on there. It's been a constant source of embarrassment and professional frustration for me. So we're going to go through the 5 phases of the Sdkbin story. Its development, the immediate disaster it racked on our company as soon as it went live, the pit of despair where for years we kind of lived with it on all of its shortcomings, and then how gradually we turned it around and we're basically delivering a version of it that can actually grow our business the way we want now. So our story with Sdkbin and what it is and what it's all about, that's the name of the product, actually begins with an earlier product we built called Phobos. Phobos is like a paid observability module for Akka.net. Before OpenTelemetry was a thing, we built Phobos on top of open tracing and a couple of other technologies. We had 2 problems when we launched Phobos. The first is we tried to do per node pricing, charge customers based on how much they use. Customers absolutely hated that. Everyone hated it. Even though they really needed to monitor Phobos, no one liked that. Okay? The second problem we had was we distributed Phobos via private NuGet feeds. Essentially, we used a service called MyGet, which was, some of you may have used it. It allowed us to have one canonical feed we owned that we published sort of like the gold master Phobos binaries to, and all of our customers were given a read-only mirror. This confused our customers like crazy and made it very hard for them to keep track of their credentials and figure out, if someone left the organization, no one knew they had access to this thing anymore, and that caused churn and sales losses for us. So between August 2018 and October 2020, we had about 3 total paying customers, a commercial failure by anyone's estimation there. So the reason why we were investing in Phobos is we knew there was demand for this product, but we attributed our failures to execution problems. The price and fulfillment were the 2 issues there. Price is really easy to fix. I just change a number on the sales sheet and it's done. Okay, that's pretty straightforward. Fulfillment, on the other hand, was not a trivial problem to solve. The issue that we needed here was we needed a fulfillment system that customers could own, where they could understand, here is the thing I have a license to. I can invite other members of my team to manage access to it. That way, I don't have this single point of failure within my customer's sort of organization for who's got the key. Well, they could spread that knowledge out across multiple people. So this was basically the beginning of the Sdkbin idea, building this fulfillment system. So the problems with Sdkbin began immediately. I created this vision for Sdkbin to solve our problem, which was being able to help sell Phobos to more of our customers. But I'm an entrepreneur, I'm ambitious. I was thinking we can make this a platform that other companies could use to sell their products to other customers. So it'd be a multi-tenant sort of marketplace from the get-go. A little bit more ambitious than just solving our own internal problems here. So in January of 2020, I had prepared basically our sort of presentation for here's what we're going to try to accomplish this year, and presented it to my team. And these are some of the actual slides kind of documenting how this is all going to work. We have always been a pretty small organization. There was me, CEO, wearer of many hats. I had hired a former startup CTO to basically be our lead for Sdkbin. He was based out of Russia. And then we had another Akadana engineer, someone who had worked on the open source project for a number of years, and he was primarily helping me get new Akadana releases out. He was not supposed to be tasked with Sdkbin at all. And we set a target launch date of August of 2020. So we have one full stack engineer, former startup CTO who's built products end to end before, who is basically going to own the entire design sort of stack for Sdkbin other than what's in my requirements. The only thing I was personally going to deliver was a cloud environment. We decided we were going to use Pulumi and Azure Kubernetes service and basically do infrastructure as a service that's all sort of source control deployed. And we got that up and running. In February 2020, a little thing called COVID-19 happened. Some of you may remember it. As the lockdowns began, I had an immediate CEO problem. 40 to 50% of our customers had to cancel their upcoming obligations with us. On-site training, our biggest customer in the world was an airline at the time. We had a lot of customers in sports betting who suddenly had nothing to bet on. I remember having a conversation with one of them where they were trying to figure out how to calculate odds on League of Legends. So it was pretty bad. So suddenly my focus shifts from this brand new opportunity with Sdkbin to basically trying to stay alive, make sure no one in the company loses their job, is what I'm trying to do. The other sort of side factor here, I was supposed to get married on April 1st. That got, as my wife in the oil industry likes to say, it got force majeured, meaning an act of God prevented it from happening. So I had that going on as sort of another parallel thread here. All this to say, Sdkbin kind of became a little bit of a side quest for me, and not allowing the company to die kind of became my primary thing I was focused on. Now, this is not an excuse for the failures that are about to happen. This is just my operating environment I was in, just to kind of set the stage here. So between Q1 and Q2 2020, the initial foundations of Sdkbin were basically ironed out by middle of February. We're going to work backwards in a second to kind of see the commit history, but we were already screwed by the middle of February 2020. The design decisions the Sdkbin lead was making are, as we'll see, horrifically bad, and not something that a startup CTO, let alone like a senior engineer, could competently make. So we'll get into that in a moment. March of 2020, we have a basically full implementation of the NuGet proxying service up and running, the primary distribution system. That's looking pretty good. And then by April 2020, we're basically successfully completing all of our integration testing with real NuGet clients. So the Visual Studio built-in NuGet client, the NuGet CLI, number of other different tools that we needed to support. We're basically passing all those tests. Looks pretty good. Here was the structural problem our team and organization had. And 2026 me would have definitely fired 2020 me for allowing this to happen. So we're going to kind of get into this. My Sdkbin lead was based in Russia. I'm based in Houston, Texas. So there's between an 8 to 11 hour kind of difference between us. Kind of depends on time of year for daylight savings, and I don't remember, he moved around a little bit. But basically, by the time I logged into my computer each morning, a full night's worth of architectural decisions had already been made. I'd given the engineer a carte blanche to go ahead and just pipeline his pull requests into this repository. We didn't have a workflow where I could sit there and interactively work with them on each one. The time zone sort of difference didn't really allow for that. So as a result, doing proactive architecture reviews were a thing that pretty rarely happened in the early stages here. And this, as it turns out, was a fatal mistake. So let's take a look. Another quick show of hands. Who's a .NET developer? Okay, you know what's coming, right? This is the dreaded generic repository pattern, which is if you want to see what a code base looks like when it's infected with cancer, this is it. So this is the sixth thing that was committed into our code base, the generic repository pattern. So what do we have going on here? First, we're going to go ahead and constrain everything to basically conform to this interface. We even have auto mapper included in here. Awesome. So, that means we're probably going to have DTO spam, where there's going to be a lot of objects that look identical to what's in our domain model. But my personal favorite thing about this sort of generic repository base pattern is how it is totally inflexible if you need multiple different views of your domain objects. You either have to denormalize everything into their own row of entities or build an entirely second system to go and work with it. As we'll see, what our developer came up with was way worse than either of those two possibilities. So basically, my developer's working. He's churning out 33 GitHub issues in a single day, planning out this big architecture. And I'm not paying attention to any of this. I'm trying to find business. I'm trying to basically get sales in here. But here's the real issue. I could have figured this out, that there was a problem, in about 10 minutes. Nothing was so urgent, I couldn't spend 10 minutes going, that seems like a lot of services for an application that has 0 customers today. Why are we building an account service, a feed service, a user service, a NuGet host service, an admin service, a billing service, and a sales service? So as it turns out, the developer wanted to build a 7 microservice deployment, each with its own database, where all of the work would be done basically with sort of these big HTTP calls spanning everything together. Now, I'm a distributed systems expert. I build high-scale actor-based systems for doing things like high-frequency trading. That is fucking insane in terms of that proposition. And that was my exact words I used to him when I finally found out that that was what he was planning on doing. For a 2-person team, you do not need this. Now, if we were Uber and we had 5,000 developers and we had a big suite of products that did a lot of different things, okay, maybe having a bunch of services makes sense in that environment. Not for a 2-person startup. Another fun one, and I don't know how this happened. So my sort of philosophy around managing people up to this point in time was hire qualified people and give them a lot of leeway to make and own decisions. Give people a lot of autonomy. But I did stipulate some very specific requirements on how this is going to be run. SQL Azure appeared on that PowerPoint presentation. We are going to be using SQL Azure. And at the time, this is 2020, it definitely did not have a managed Postgres service. How we still ended up picking Postgres anyway as his backend for that, despite it being one of the 5 explicit architectural requirements, is a failure on my part to make sure he understood what the restrictions were. So even though you could go ahead and lay this at the feet of, let's say, a reading comprehension problem, when you're a manager, it's not enough. This is a lesson learned here. It's not enough to give someone requirements. You've got to make sure they can narrate it back to you and understand the reasoning for why you chose that. In our case, this is just SQL Azure was just the easiest and cheapest thing in our environment. We didn't want to have to worry about database backups or redundancy. SQL Azure kind of gave us a pretty low-cost way of getting all of that. So this was the question my developer asked me in May of 2020, right after all the integration testing passed, because it looked to me like artificially everything was going pretty great with the project up till this point. I didn't see a clear need to stick my nose in yet. But he asked me this question on one of our morning sort of calls where we talk about what got done the night before. Hey, who are you planning on hire to build the front end? Now, bear in mind, this is like late May of 2020. We're supposed to be launching in about 2.5 months. The amount of time it takes to hire someone, onboard them, and get them to actually deliver something, as a startup CTO, he would know that's a very, very tight deadline to get anything done. So my instinct kind of, at this point, comes into play, and I say, okay, I need to start turning over some rocks and figuring out what the hell broke down in our communication here. So I took the project back under my control. At this point, essentially I actually took away his merge access immediately after that conversation. I'm like, nah, I'm reviewing all your pull requests going forward. He described himself as a full stack developer. He had shown me his portfolio work, looked really good. As it turns out, other people had done all the front end work at his previous jobs. So that was a problem. I gave him like a 17-slide deck with a bunch of user flow diagrams on it and 21 interactive balsamic mockups kind of showing what the user experience should look like. Explicit UI flows. He didn't really have, let's say, a lot of experience figuring out how to implement that. And that didn't get communicated to me until, even though I walked him through all of that early on, that didn't get communicated to me until way later in the project. So we panic built the entire UI using Razor Pages, which of all the technologies for doing ASP.NET Core, Razor Pages is probably the worst out of a lot of them for a variety of reasons. But the reason why we picked it was that was the shortest path between this gigantic HTTP API system he had built, intending to have someone build like a micro front end for it, and what we could actually deliver to customers meaningfully quickly. And we pushed our launch date from August to October. I pulled my Akadata engineer off of his project. He was a mobile game developer, and he had done a lot of browser-based games before. I was like, congratulations, you're our front-end engineer now. Had to do what we needed to do to try to ship this. Now, this is what happens when no one reviews the architecture. I have so many of these slides I had to cut for the sake of time. This is what I call code gore, where it's just, we're going to look at some pretty violent looking bad engineering decisions here. So this is one of our Razor Pages. And what we're going to count is, let me just take a step back. I want you all to count with me the number of different repositories being injected. All right? We have the products repository, the subscriptions repository, the subscriptions helper, which, by the way, also takes a subscriptions repository as a dependency. So we're injecting it twice. The emails helper, which takes another repository. And then the user manager, which also takes a repository internally. Essentially, the way that this stuff was kind of being modeled out was, rather than having this sort of sense of here's a view and here's all the different tables we need to query in order to actually populate it, we're going to glue gun everything by taking these little generic repositories and essentially joining the results of all of them in application memory. So about the most inefficient way possible to work with SQL. But it gets worse. So what I was showing you before was like the code behind, that's like the controller portion of Razor Pages. This is the view. This is the stuff being executed in the renderer when we're doing server-side rendering. We are going to inject a feed repository into that view. And we're going to, for every single item in a feed, we are going to do a round trip to the database and render the partial that way. So, quick show of hands, who's familiar with the term Cartesian explosion? This is a Cartesian explosion on a public-facing page that requires no authentication. It's the product display list for a vendor. So every time Google would come to index this page, we would get an alert that our site was down. Because of the sheer amount of, this basically would max out our DTU budget on SQL Azure. We had no traffic, but I had to spend about $400 a month on DTUs just to stay up. Now, we do end up fixing all of this later. But these are the types of problems that my supposed startup CTO is introducing. So what kind of made all these architectural problems inevitable is this repository-based decision essentially cursed the entire design. it produced n+1 queries everywhere, where you'd have to go ahead and run essentially for for all the entities you needed, you would do at least that many +1 requests to the database each time. And every single feature was built on top of this repository-based monstrosity. And one of the things I tried to stipulate with this project was I wanted to be hands-off, wanted to let the engineers build it, did not want to basically get in their way. And as a result, we eventually dragged the project across the finish line and launched in October of 2020. And then this is where it gets really bad, when we actually make first contact with paying customers. So October of 2020, part of the reason why there was this deadline pressure for us to try to get this thing out is we had made promises to other publishers that we were going to try to get them on board. We had made promises to our customers that Phobos's price was going to be reduced and would be easier to purchase in the future. So about 3 weeks or so, maybe 2 weeks after we go live, Sdkbin achieves its goal of allowing someone to just run a credit card and buy Phobos without having to go through a procurement department. Awesome. So the customer runs their credit card, and then nothing happens. We take their money, they get no product, no email, nothing. So naturally, I panic and try to figure out what the hell's going wrong and how are we going to make this right. I wake up my developer in the middle of the night and tell him about this, and his response to me is, well, that's great that we were able to take their money. I'm like, no, man, no, it's not great. So almost nothing worked correctly. The payment system shopping cart stored the price in the cookie. So if you wanted to set your own price by using like Chrome dev tools, you could totally do that. Great. We had to basically fix that exact security bug 3 different times until finally it got patched. That was awesome. The actual NuGet feed for distributing our products kept timing out because of the package upload size for it. Great, had to fix that. My personal favorite of all the Cartesian explosion things he did, when you're trying to keep track of, let's say, statistics inside SQL Server, you want to perform what's called an aggregate on write strategy. When the update comes in, you update a counter that is like condensed to a specific point in time. What our developer did was he would insert a new row representing that download event. And so if you wanted to go and pull a report of all the downloads per day across every customer, every package, and every version of that package, so we're looking at 4 or 5 dimensions of data, he would count all of them every single time. So that worked great when you had 2 packages with no downloads and you're testing all this locally as a software developer. By about 30 days worth of actual use, this page would not load anymore. So we had to go and essentially denormalize all of that. We wanted to have an automated onboarding pipeline, totally dead. Customers signed up and got nothing, so that didn't work. Lots of tenant isolation problems, cross-organization data leakage. These are all things, by the way, I was told were fixed before we went live. Renewals. This is my personal favorite. The billing actor only checks the day. These are annual subscriptions. The billing actor only checks once at midnight the day that renewals due. If that renewal gets missed because that actor failed to run or failed to start, that customer gets free product. We found that a year later. That was awesome. Good one. So another awesome issue that we found maybe a few years later in Sdkbin. The way we were managing billing methods using Stripe was basically using the Stripe SDK, and I had assumed that the way we did it is we would save like a non-PCI prefix for the billing method ID from Stripe in a database, and the users would set their preference for what they wanted to use for like a renewal. No. We would set basically what their preferred payment was, but in the event that that preferred method wasn't available, we'd try one of the backup methods. Well, guess where we source the backup methods from? That would be the user's Stripe account. So if they ever added a new payment method for a totally different vendor, we would run it. And so this cost a customer $4,000 last year that had canceled their subscription, where it came for renewal. They hadn't actually gone through and checked the box to cancel it. Instead, they had just kind of canceled that credit card. Well, we found another credit card and ran it anyway. So awesome. Yeah, that was great. I refunded it. Cost me about $400 in transfer fees, but that was pretty embarrassing. So the picture I'm trying to paint here is that despite all of Sdkbin's problems, we were actually getting business. We were selling more Phobos. The pricing change worked. We were able to start getting more people actually using the product. So all of my commercial hopes for Phobos were starting to get met here. But behind the scenes, it was constant stress and firefighting. So the management issue we're about to run into here is, what do I do with my developer who's basically owns Sdkbin? Well, I was paying him over $100,000 a year, US. Pretty awesome if you're a Russian software developer. I had to spend a significant amount of my time during our best sales quarters in 2020, essentially double checking all of his work and filing issues and doing QA, doing stuff that is not what I would describe as like a revenue growing activity. So I spent 2 quarters doing all of that. And one of the things that suffers as a result of me not being able to spend more time on sales and marketing is sales go down. So we basically had an immediate revenue crunch at the beginning of 2021. The other factor that impacted that was in 2020, everyone had hope that the COVID lockdowns would end. In 2021, that sort of position our corporate customers had was more like, nah, we're probably going to be in lockdown for another year. And so we're going to slash everything to the bone, more or less. So that impacted us too, but lack of sales and marketing hurt big time. And then the downstream damage of all these decisions is that every single one of these bad architectural decisions, and we're going to get into a lot more of them, basically impeded our ability to ever make Sdkbin available to other publishers. To this day, we still don't have any other publishers on Sdkbin, and it's going to nerf our ability to sell additional products and services through it too. One of the things I did to try to keep the company afloat during all this financial strain is I cut my own salary by 40%. My Akadana engineer cut back on his hours. And I'm expecting my first kid while all this is going on. And my wife had just quit her job too. So I'm basically under a lot of personal financial stress. I asked our engineer in Russia, I was like, hey, are you willing to take a cut like the rest of us are to keep the company alive? And he lets me know that him and his wife are just finished buying an apartment building as an investment. Now is not a good time for him to reduce his salary. So being the nice guy that I am, I decided not to do anything about that. Now, eventually my patience ran out though. One of the things I wanted to fix was our email onboarding experience. We had transactional email code spread out in like 1 million incomprehensible places. And what I really wanted was the ability to send onboarding directions when someone buys the product on here's how you get people on your team, here's how you install it, here's how you use the dashboards that come with it, sort of basic post-sale marketing stuff. So I gave our Sdkbin engineer basically a quarter to go ahead and work on engineering this. And we were going to use Azure Event Hubs. Essentially, we were going to emit an event when a campaign needed to fire, and that would cause us to schedule sort of a drip of emails that would go out. He basically came up with 3 different ways over the course of a quarter how not to build this. And the final commit he made to the Sdkbin codebase the day before I fired him was deleting 3 months worth of his work because he could not make it work. Ironically enough, he had basically trapped himself with his own architecture. It was so inflexible and so brittle that trying to essentially work the wood to add these new requirements proved impossible for him. So at that rate, I basically threw in the towel and decided that this was no longer salvageable. So that's basically end of Q1 of 2021. We spend the next 3 years just kind of coping with Sdkbin's numerous faults. We were able to get Sdkbin to the point where it mostly worked. We gradually fixed some of the database performance issues, and we didn't really address any of the big domain limitations it had. Sdkbin was like super ultra coupled to Stripe, And we have corporate customers, about 60% of which want to use purchase orders. So we had to have a whole manual system for reconciling renewals that did not touch Stripe at all. Yeah. So one really big problem we had here is we would basically use some manual SQL scripts to go and reconcile, okay, this customer wants to pay via purchase order, here's their new renewal dates, and we would go ahead and do that to kind of move their subscriptions forward. Let's see. Maybe I took this slide off of here, but the way the Sdkbin developer originally wrote the renewal code was, rather than having like a ledger kind of showing all the financial transactions, here's the payment that's due, here's the invoice amount, here's when the invoice was settled, here's when the subscription renewal date begins, doing like accounting like we've done for 500 years. The way he would manage a renewal would be changing the creation date of the subscription, adding a 1 to it on the year column. So we basically didn't have a lot of good history inside the billing system either. So I decided one day, you know what? Maybe we should go ahead and try actually really cleaning up Sdkbin architecturally. Like, we've kind of done all these Band-Aids. We haven't really had a lot of time and resources to go into it. This is like 2023, I think we did this. And I decided, you know what? I'm going to try getting our tests cleaned up. And the first thing I'm going to do is I'm going to enable nullability in .NET. That way, all of this crazy join spam that's happening inside the Razor pages, I can finally get some of that under control. I turn on nullability, and 100% of our unit tests fail. I haven't actually changed any code yet. I've literally just enabled that feature, which is optional. And this startles me, and I realize what the issue is here. This is a super database-driven application, but none of the tests actually use SQL Server. They're all using the in-memory test database, which means the schema changes when you change the C# type. It turns all the columns into nullable, which breaks all the joining semantics on it. So I have zero confidence in our test suite. And as I dig a little bit further under the covers, I see what actually did get tested. There's a whole bunch of middleware for AutoMapper and Fluent Validation and blah, 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 that all got tested. Our actual pages where we handle people's credit cards, where we handle their registrations, and where we actually have our buy path for doing sales, that is a 0 on the code coverage report from JetBrains Writer. What our developer had done is he built a ton of HTTP APIs, the ones he was going to build those micro front ends for, and rather than extract some common services out of those and rewire them into Razor pages, he literally rewrote everything. And all of his tests cover the old APIs that never have served a single HTTP request's worth of live traffic. So we effectively had a test suite that told us nothing about how well our code base worked. So we had made 3 different attempts to try to basically free ourselves from all the problems Sdkbin had. The first was we tried to triage everything in early 2023. This is when I found all the nullable tests and everything. That didn't work. In 2023, in Q2, Q3, Q4, we tried to do a full rewrite of Sdkbin from the ground up, design it from scratch. We had to abandon that because the integration risk with the old billing system was just way too high. Yeah, the odds of something going wrong was pretty rough. And ultimately, we wasted lots of cycles trying to find a way around this problem, trying to either triage it, trying to basically band-aid it, or trying to rewrite it. Finally, me and the Akadana engineer got angry enough that we decided to just attack it at its base, to solve the problem basically from the ground up. So in October 2024, we got a customer email saying that they could not use NuGet search with Sdkbin. They had bought Phobos. They were trying to basically use the search feature in Visual Studio to install it. And they said they even profiled it with Wireshark. And they said, yeah, it keeps timing out on the back end. And I go and I take a look, and I realize that part of the problem here is that we've never addressed the really bad SQL architecture under the covers. This is a hack I included sometime in 2021 to stop that endpoint from timing out, which is if the query string does not start with P, that's our Phobos package, go ahead and return empty. When a NuGet client restores all of its packages, so if you have 200 packages basically installed in one of your solutions, NuGet hits every endpoint for every package at the same time. So Sdkbin would get requests for packages we never hosted. This was our way of cutting down traffic on that. But I took a look at this emergency workaround, and I thought, we've been trying to get away with total bullshit on this project for years. It's time to actually go and do something about it. So the strategy that we were going to do was a strategic refactoring, strangler fig pattern, if you've ever heard of it. And the first thing that needed to be fixed was the NuGet package layer. That's the most performance critical part of our site. That's the thing that gets hit hundreds of thousands of times a day. We need to go ahead and begin repairing the damage there first, and then gradually spread it to the more complicated parts of the application, like the billing system. So we were going to begin replacing pieces of the old system incrementally. Keep the system running, do it live in production with paying customers, but be smart about it. So here's what we ended up doing. The first thing I decided to change is there was way too much stuff that was not documented in and decisions we made and why we made them at the time. When I was preparing this talk, I went through, I'm a pretty meticulous note taker for the most part. I was able to go through some of my old notes in 2020 that I had kept, and even those were pretty sparse. So one thing we decided to embrace early at the very beginning when we started doing this new engineering sprint was writing down architecture decision records. Here's the problem we have. Here's the proposed solution. Here's how we're going to validate it. And we've got about 17 of those that are committed into the code base now with live solutions that are up and running. I've got another really large pull request we haven't staged yet that basically replaces most of the billing system. That has another, I think, 8 or 9 ADRs built into it. So the strangler fig in action. First thing we needed to do, our authorization system with Razor pages is essentially untestable. Now, that's not the Sdkbin engineer's fault or my fault. That's just kind of honestly a limitation with Razor pages. It only really allows you to have one sort of unified authorization policy for all the routes on a given page. So what we decided we were going to do, we were going to build an authorization system that was scopable and testable using roles. We already had a good roles-based authorization system, but the problem was just enforcing it, testing it appropriately. So we did that. We decided we were going to move off of Razor pages and onto just MVC controllers so we could essentially enable more fine-grained permissioning on all the routes. And I think we're down, this is a little old because I gave this presentation a month ago. I think we're down to only 12 Razor pages left out of the original 90. Everything else has been consolidated into controllers. So basically what we would do, delete the page, create an MVC controller, and then we introduced a more solid pattern for actually being able to surface stuff up to the view. We basically embraced CQRS, is more or less what we did. Command, query, responsibility, segregation, where the way entities are stored in the database is sort of not related to how they're presented to an end user in these different contexts. We would distill a view. And the pattern we used for this is this sort of view context approach where when you're serving a web page, there's some information you need on every page, like the name of the vendor or the name of the product or the name of the customer. But there's little fine-grained details that get changed, like if you're looking at billing or if you're looking at product usage or you're looking at access control, that stuff can get swapped around. So we basically built this composable view context system that could just essentially compose reusable components with bespoke ones and return a good view that way. The other thing that was interesting is this is around early 2025, late 2024. AI coding was good enough even then to start helping us essentially clear the log jam inside our system. The big problem that we had early on using AI is if you're using a tool like Cursor or Claude Code or maybe Copilot, the code that is already in the code base is like the strongest center of gravity for what the AI is going to infer. So if you unleash AI without looking at it closely and you have all these horrible anti-patterns you're trying to get rid of, what's the AI going to do? It's going to keep using them over and over again. So what we had to do was basically put in like, if you've ever done construction, you know what a pony wall is, like a temporary wall that kind of supports the structure. We had to do the software equivalent of that, where we essentially cut out an area where we were going to manually set the new pattern and then told the AI, like, okay, this pattern is good, all other patterns are bad. Go ahead and find bad patterns and begin like, writing planning documents to replace them. And then we basically had another AI that didn't have any context on what the old stuff was, just follow a written plan all the way through. And that allowed us to kind of pave the way through a lot of it. So a good example of how we kind of transformed part of the back end here. This is what I was talking about with that razor page authorization policy stuff. We were like stringifying these different policies. I mean, this is just ugly code on the left here. This is what we had before, where we were stringing policies together like, okay, this is a customer that requires admin access in order to modify billing methods. All right? That is pretty difficult to test and pretty difficult to sort of explain to someone who's not all that familiar with the code base. On the right, we have this, what I call a stackable authorization system, where it's all like resource descriptors. You have entity of type customer, sub-entity of type organization, sub-entity of type, or basically a claim, right billing on there. And we have exhaustive unit tests now that can basically assert all the tenant isolation and all the, sort of within one tenant permission, like granular permission separation on there. So we have 100% test coverage on our authorization system now. That was an early goal I had, was trying to get some sanity restored around that. Now, when we realized we could actually start making some progress here, we fixed the performance issues with SQL. We had a good model for how to fix the authorization and tenant isolation bugs we had. We were able to kind of really start ripping through it. And as AI improved, which you can see right around the middle of 2025, Q2, Q3, Q4, it allowed us to really speed up quite a bit. We never let AI design any of the domain entities ever. We never let it do that. We design those, and we go and write the POCO classes ourselves. But what we have are some established patterns of, here's how we round trip these to the database. Here's how we decompose these into view context when we need to. And we'll let the AI cook on that stuff, but just not deciding what the entity should look like and what boundaries it should have. That's delegated to a human engineer, always. Now, this is probably a little small to see. This is another problem that annoyed me for years. Generating links in transactional emails. So a customer buys a product, we have to send them a link to the API key page so they can get their credentials to actually install it. This would break all the time. Even doing something simple like upgrading the version of ASP.NET Core we were on could break this. So one thing we decided to do was build some classes that could use the HTTP context and a couple of other pieces of information to generate links and also generate a fully rendered transactional email. And then we use the verify library to do snapshot testing on that. So if anything and all of that machinery around transactional emails changed, we'd get an instant failure back and we wouldn't deploy the system. So gradually trying to use the test suite to give us healthy signals if we're breaking something or not. Then there's the billing system, which is the biggest pain in the ass in the entire Sdkbin codebase. The old system has one actor per server that runs on a timer and races to bill customers. There's no coordination. If we have 4 instances of our billing system in production, there's no coordination between any of these actors. They rely on optimistic concurrency via the database. The other problem here is that it is extremely tightly coupled to Stripe. The developer who built it originally decided to turn invoices and Stripe payment receipts into the same thing. Those are completely different domain concerns. They have a relationship, but they're not the same. So it was a lot of baseline sort of architectural decisions like this that all had to be revisited. You can't fix this by writing a better SQL query. You've got to take the old models and replace them, is what you have to do. There are also a lot of other business requirements, and this is not anyone's fault. This is just stuff we discovered as we started working. Grace periods. This is where, no disrespect to anyone or anyone's companies, the people who work in large corporate procurement departments are not exactly the sharpest people in the shed, usually. So they forget stuff, they run late, or they simply, as company policy, always pay late. We get panicked emails from the actual developers who depend on this product because it's part of like their CI/CD system to go live. Please don't cut us off. Our procurement department's running behind on paying your invoice, blah, blah, blah. We have to have a domain concept for modeling that. We call it a grace period. And these are all things that all needed to be built into a real billing system. So this has not made it into production just yet, mostly because I need some more time to just sit down and do QA on it. But we've used Akka.net, our technology, to basically represent subscriptions as essentially long-running finite state machines. A saga, if you will, is more or less how it works. And this is one example of a behavior from the subscription actor where we're basically in the state here where we're waiting for an invoice to be generated. We've hit the point in the billing cycle where it's time to invoice this customer. And we have all these little bits of detail that we need. We need to issue an invoice creation command to another actor responsible for doing all the line items and currency conversion and tax and all that. Generates an invoice for us. And then when we get that invoice number back, we go ahead and we shift behavior to basically actually sending the invoice to the customer, and then we wait for payment. We might sit in that state for 30 to 60 days, depending on the payment terms. And this allows us to sort of conceptually model what happens when a customer is late on a payment, what happens after 3 renewal cycles. We can simulate time with this design if we want to. We can simulate how a subscription performs over 3 years. Not something that was possible with the CRUD-based, timer-based system we had before. This gives us a lot more confidence about how well the system is going to perform for us over a long time horizon. We have some customers on Sdkbin that have been paying with a credit card for 5 years now. That's a real scenario. If we want to keep selling more products, we want to start doing things like monthly subscriptions, or we want to start doing pay per seat, all these more complicated billing arrangements. We need a good foundation for being able to test all of that. Having some, let's say, saga actors kind of run that for us that are all very testable and we can virtualize time gives us the ability to do that in a way we didn't have before. This is how big that pull request is with the subscription actor in it. And this is about 80% of this is all tests, trying to basically cover all these business scenarios that never got any real testing at all before. Trying to basically give us some confidence that this system is going to be stable. It's going to be able to support a much larger set of business rules and a much larger set of payment providers with a much larger set of products. It's not just fixing our domain, it's expanding it. So where we are now, a couple of specific technical things we did to kind of help rebuild the system. So when I discovered that we had 0 effective test coverage, that was the first port of call I had to go and fix. This is an area where AI is super useful. I used .NET Aspire, and I used the .NET Aspire testing system, where it orchestrates your entire application. And the way we tested it was we fired up Playwright and basically did all this validation that these end-user scenarios could be completed, clicking from page to page to page. That is not something I would recommend as your primary testing strategy because it's very brittle. As soon as you redesign your website, all that stuff breaks, right? But in order to try to basically get as much stuff under as a few tests as possible, that was a pretty good way of going about doing it. We threw those tests away once we decomposed everything. But that kind of got us from 0 to somewhere. So we did that. The dynamic sort of policy for doing authorization, again, great idea. It made it so all this multi-tenant stuff could actually be tested. And you could even test permissions like exhaustively within one tenant, which is good. AutoMapper. I have a note that the day AutoMapper is deleted out of Sdkbin's codebase, I am buying a high-end espresso machine for the office. So that's still a goal. We're not quite there yet. Architecture decision records. The sort of culture of writing things down and explaining why we did stuff is just as valuable for people as it is for LLMs, if you want to basically have them work with you on your code base. We're not done fixing Sdkbin yet. There's still a lot more work that needs to be finished here, but I'm no longer embarrassed by it. And this story was, 6 years in the making. Definitely the biggest professional embarrassment of my career. I have changed a lot about how I interview people, about how I manage projects, about how I make sure requirements are sort of understood and are appreciated. And then I'd say probably the biggest thing is taking the time to go look early in a project. Don't make the excuse that I did, which is that I had bigger fish to fry. You can take the 10 minutes to go look and find problems really quickly and really early and have those conversations. So if you're sitting on your own version of this, where you suspect there's trouble brewing in a project and you're not sure what to do about it, the first course of action you should take is go have a look for yourself. Turn over rocks, see what's underneath them, and if there's problems, time to surface that now, rather than wait years and years before it builds into a monumental failure like Sdkbin's been. And that's it for my talk. If you have questions, I'd love to take some now. Thank you very much. Any takers? Nope. All right. Well, I'll be happy to take questions out in the hall, assuming I don't lose my voice any more than I already have. Thank you very much.